Hi friends, this video we are going to solve this transportation problem. So what is the question is given? The power co company must allocate the electricity from its 3 plants to 4 cities. So then the supply capacity of each plant, the demands on each city and the per unit shipping costs are given in this table. So first of all, so this is the given. So they have the 3 plants will be there. There is a 3 source. Then and 4 destination, because city 1, city 2, city 3. So 4 destination will be there. And supply and demand. Supply is 35, 50, 40. Demand is 45, 20, 30 and 30. So first of all, it's balanced problem or not, we have to check it before going to proceed. Yes. So what is the supply is 35 plus 40, 70, 85, 85 plus 40, 125 supply. Demand is 45, 65, 95, 125. So this problem is balanced one. So if it is not balanced, we have to do some dummy row or columns. We have to do it. So this problem is balanced one. So we have to proceed. So now I want to make the table of the cost. So city 1 to plant 1 to city 1 is 8 rupees. City 1 to plant 1 to city 1 is 8 rupees. Plant 1 to city 2 6 rupees. Plant 1 to city 3 10 rupees. That is the given. So same thing only I am going to copy. Plant 1 to city 4 9 rupees per unit. So 9, here you will get it as 12, here is 13, here is 7, here is 14, here is 9, here is 16, here is 5. So supply is, so you write here is supply. Supply is 35, 50, 40, here is 45, 20, 30 and 30. So this is demand. So first step, what I want to determine the initial feasible solution to. So initial feasible solution we can, there is a 3 methods will be there. One is Northwest corner method. Second one is least cost method. Third one is Vogel's approximation method. So in this video, we are going to see these 3 methods how to use it. So the Northwest corner method is very simple method. So first I want to give, first I will send the northwest corner. So this is the northwest corner, I am starting point. So I want to give maximum allotment in the northwest corner first. So here 35, here 45. So maximum how much I can give? Here I can give maximum 35 I can give. So here means, so supply is over. So demand is reduced from the city 1 is remaining is 10 only there. So next step I want to go to down. Here is I want to give 10. So here is 40 will be there. So city 1, what are the demand is required, everything is completed. So now you go for the plant 1, remaining 40 units will be there. So I want to give to the city 2. City 2, how much I require, demand is 20, supplies I have the from plant 2 is 40 will be there. So remaining I have 20 I can place. So city 2 requirement also it's over. Now I have the plant 1 have the 20 units remaining in there. So I will transfer to the city 3 20. So this 20 over. So everything is over. Now here demand of city 3 is 30, but I already allotted 20. So 20 over means remaining is 10. Now I am going for the 10 from the plant 3. I give the city 3 10 unit I will give. So supply is reduced to 30. Now finally 30 units give to the city 4. So everything is completed. So now I want to, this is the initial basic solution, feasible solution. So total cost is equal to 35 units times 8 rupees plus 10 units, each unit is 9 rupees for the transportation cost, 20 times 12 plus 20 units times 13 rupees plus 10 times 16 plus 30 times 5. So the total cost if you are add together, you will get the answer is 1180 rupees you will charge if I transfer using the Northwest corner method. This is very simple. I am starting from the here only I am starting this cell. Then I want to give the maximum allotted give to the Northwest corner only first. So this is over. Then I go the next Northwest corner is this one, because this is and this will over. So this cell is the next Northwest corner. This is over. Next Northwest corner is this cell only. So that is why this Northwest corner method will work. Second is we are going for the least cost method. Least cost method means again I want to give it the cost, everything I want to fill it in the table. So this one is 8, 6, 10, 9, 12, 13, 7, 14, 9, 16, 5. Now I am going for the least cost method. Least cost method is nothing. I want to give the maximum allocation is in the least thing only. So supply is 35, 50 I want to write. Another is 40. Here is 30, 20, 45. So the first I want to give the maximum, I want to give the minimum cost. Where is the minimum cost? Minimum cost is 5. So I want to give the maximum allotted. So I can give 30 here. So this, the city 4, what are the required is 30 units. So it's already over. So supply from the plants is simply 10. Next minimum value, minimum cost is here. So here I want to give the maximum amount I want to try to give. 20 I can give. Here is 50. Next is minimum cost is 7 is there, but already city 3, what are the demand is 30 we already allotted. So we no need to consider this one. So this is already over. Okay. So now I want to, the minimum cost is 8 only. 8 I can give maximum. Here the plant 1 supply is maximum I can give 15 only. So the 15 here. Next is minimum cost I want to look at. The mixing minimum cost is, so this row also hereafter over, okay, this row. Now only these 6 cells only I want to consider. 6 cell, what is the minimum element is 9. So I want to give the maximum. So already I allotted the 15. So remaining is 30 only will be there. So here I can give 30. So then 50 minus 30 is 20 units will be there. So this column is completed. Now remaining these 4 cells, I want to give the max. What is the minimum cost? Minimum cost is, I want to give what is this 4 cell minimum cost is. So the problem is this is also already allotted because the 20 is over. So only these 2 cells only I want to consider. Here is I can give maximum 20. Here I can give the 10. So this is the least cost method. So I want to try to give maximum of the minimum cost only. I want to initially I have to give. Then total cost equal to, we have to give 15 times units times 8 plus 20 units times 6 plus 30 times 9 plus 20 times 13 plus 10 times 16 plus 30 times 5. So total values you will get it as 1080 rupees we will get. So Northwest corner method we obtain 1180. The least cost method if we are implement, we will only cost is 1080. So this method is somewhat better than Northwest corner method. Now we going for the third method. Third method is Vogel's approximation method. Vogel's method. So what is the Vogel's approximation method means? First we want to find the row penalty and column penalty. Here we can say row penalty and column penalty. So what is the row penalty means? I want to take the least 2 cost and their difference. So what is the least cost of this difference is, here we have the least value is 6 and 8. So their difference is, we can write it as 8 minus 2 is, we will get it as, so difference is 2, and here least value is 7 and 9, their difference is 2, and here is difference is 5 and 9, difference is 4. The column penalty is, if you want to take it, here you will get it as 1, here you will get it as 3, here you will get it as 10 and 13, so difference is 3, here you will get it that 2. So now I want to find the maximum penalty where, so maximum penalty is 4, okay. So that row only I want to give the allotment. So what is the allotment I want to give? What is the allotment is, I want to give the, what is the least cost, I want to give the maximum allotment. So I can give here is 30 and 40. Can I give the maximum is 30 only I can offer. So that is why the demand is satisfied. So supply is over. So remaining is 10. Second step I want to do the penalty. Row penalty only I want to find. But the problem is this column is already completed. So you strike it out. So remaining place only I want to, row penalty I want to do it. Rho minimum value is here 6, 2. So again we will get the rho penalty is 2 here. Here what you will get? Penalty is 12 and 9. The difference is 3. Here the difference is 9 and 14 is 5. So this is column is already over. So you put the dashed lines. So here the minimum two values, that is 13 and 10. So you will get it as 3. Here you will get it as 6 and 9. So 3. Here 8 and 1. So we will get 1 again. So what is here is the maximum penalty is 5. So in this row I want is the minimum cost is apart from that is 9. So I want to give the maximum allotment 10 I can give. So this is 10 is reduced. Now you look, this whole row supply is done. So this row I cannot consider. So that is why you put it as dashed line here again. Now again I want to do it the process again. So you will get that 6 and 2, you will get the rho penalty is 2. Here is penalty is 3. So this column is over. So 10, 3. This column is already completed. So 6 and 12, the column is difference is 6 here. 8 and 9, we get 1. So what is the maximum penalty? Maximum penalty is 6. So here what is the least value? 6. I want to give the maximum allotment, but I can give 10 only. The reason is here is 35 will be there, but the city 2 is required only 20 units only. So this 10 is can. So here become 25. Remaining supply will be there. So this column also I make it as a dashed lines. Next I want to, so this row I want to strike it out. This row is not there. Fine. Now remaining is 8 and 10. Penalty is 2. Here is 4. Here is nothing. Now the column is I want to call 1. Here is 3. Here is already over. Correct? So now again row penalty maximum is here only. So I want to say what is the minimum is 9. What I want to give the maximum value is here only. Correct? So 45 and 50 minimum is 45. I will allot here. So this is also over. Here remaining is 5. So this is over. Next step also I want to do the, so this row is I want to strike it out. This row is not required. Only what is the row is there? Only these two cells only freely available. So this directly you can substitute because only one thing there. Here 10 will come. Here so you write 25. Here remaining is 5 you can strike. So we will allot it. So now I want to calculate the total cost. What will come? 10 times cost equal to 10 times 6 and 25 times 10 and 4 plus 45 times 9 plus 5 times 13 plus 10 times 9 plus 30 times 5. So the total cost is, if you are calculate, you will get the 1020. Okay. This is the Vogel's approximation method. So these three methods will suggest that how to find the initial basic feasible solution. It is not the optimal solution. Okay. So to find the optimal solution, we are going to use the modified distribution method that people will call as a MODI method, or some people they call it as a UV method. We will see in the next video. Thank you for watching this video.